Before I welcome our guest, I'd just like to invite those who've not already done so to please subscribe to our YouTube channel, Magnimind Academy, where we upload recorded sessions of these talks so you can watch them later. And also feel free to comment any questions or thoughts on the comment section below about what you think about today's talk. So now I'd like to welcome Sunmoo Yoon and her talk on AI and machine learning to support and improve health among African American and Hispanic dementia caregivers. We really try to find speakers who can give different workshops like these, who can give different information or just a different perspective to go along with our data science education programs. And these programs range from focusing on the fundamental skills of data science all the way to helping your entire career change into the industry. Our goal at Magnimind is impacting as many careers as we can, and this is just one way that we do so. Yoon joins us from Columbia University, where she has worked as a research scientist for the past 10 years within the Data Science Institute. Her focus is utilizing visualization and data science in order to reduce health disparities, and part of her research is analyzing social media cues and applying natural language processing, and she has also contributed groundbreaking research that helped combat the Ebola virus. Before working as a research scientist, Yoon was a nurse working in and around New York, DC, and Seoul, receiving her BS in nursing from Seoul National University, and then went on to get a master's in nursing informatics from Columbia University. We're really excited to have her, and please now give your full attention to Sunmoo Yoon.
Thank you, Tom. Hi, everyone. My name is Sunmoo Yoon. I'd like to present about applying artificial intelligence to support and improve health among African American and Hispanic dementia caregivers using Twitter. So today, I don't have any conflict of interest, and today I'd like to talk about two things. One, let's just stay away from Twitter first. I'm sure that many of you are tired of Twitter nowadays. So the first one is based on this, the first paper, which just came out and received the Best Paper Award from the international conference. And then the second one, I'm going to talk about the Twitter. So as Tom introduced about me, then I've been teaching about data science and data mining, machine learning for the past 10 years. So I don't know much about the audience, except many of you are programmers and computer science background. And I only can see, okay, I only can see the question and answer, that window from my screen. So if you can tell me who you are, and I will know more about you, and which background, which discipline. So for the part one, as I mentioned previously, I'd like to talk about using the conventional data set, which is open to the public. I will introduce you in a minute. That computer science, hi. All right, great. So fortunately or unfortunately, I only got the attention using the Twitter in 2015 from all of the world, but I did not get any award from the conference. However, the technology conference. However, this year I received our team received the award with using the conventional data set. So it's not a bad idea to use the conventional data set and have some rest from the Twitter, right? So as you all know, okay, technology person with 20 years of industry, wow, that's awesome. As you all know, the importance of the background, the name, and methods and results and discussion. So I don't think I can probably, with your background, I will probably more focusing on the discussion for this talk. So the paper I just mentioned that we just received the award, the Best Paper Award, was using the conventional data set regarding the mild cognitive impairment among the Black and Hispanic caregivers. So dementia caregivers. So mild cognitive impairment, which I'm going to call that as MCI, is defined as the symptomatic pre-dementia stage on the continuum of the cognitive decline. Probably you all know that the COVID also have a problem with the cognitive difficulties as well, with as a result of unusual immune pathway. So immune response pathway. So 1 in 5. So we're concerned about the COVID, the long-term effect, and probably as a clinician, probably I will in the future I will do the research on the cognitive decline among the people with a COVID. With a severe symptoms. So 1 in 5, which is a lot, right? 1 in 5 Americans. Let me see. Okay. So 1 in 5. Can you see my laser point? Home care agency. Okay. Hi. Nedi. All right. Awesome. So I can talk more about the health side too. So 1 in 5 Americans ages 65 or older, which is a lot, right? So Spain is just blocking my slide. So have a preclinical Alzheimer's disease, MCI, which I just introduced. The prevalence is MCI, unfortunately, is higher in Blacks than non-Hispanic whites, 27% versus 19%. And 2 protein, including plaques, as you can see in the picture, these are the plaques outside of the synapse. Plaques and tau inside of the cell, the blue are the tangles, abnormally increase in number during aging and in Alzheimer's disease. But no medications are currently available for MCI. So on the right side, as you can see, this picture is a MRI picture image. So normal, and in the middle is mild cognitive impairment, and on the right side has Alzheimer's disease brain. So as you can see, the middle part is getting darker, which means it's getting empty. So it's shrinking. As you can see, the brain part here in the middle is shrinking when we have Alzheimer's disease. And as I mentioned, that the Blacks has higher instance of mild cognitive impairment. I'm trying to forward my slide is okay, my slide doesn't. So AI, probably with the background of computer science, you all know that AI uses machine learning algorithms in software to surpass human cognition in the analysis of complex health data. And machine learning algorithms are capable of discerning accurate and precise patterns from highly complex medical data in genetic, social determinant, behavioral, and environmental factors. As you can see in the Nature Medicine, published the High Performance Medicine, the Convergence of the Human and Artificial Intelligence. I strongly recommend for you to read this paper. That this figure was from the paper. As you can see, AI is now widely accepted. Before it was not even last year, but now it's getting more and more widely accepted by the healthcare providers and researchers. So AI, the products of AI, have been accelerated by the FDA approvals of the AI. And then, as you can see, the CAT scan in 2018. The researchers used the CAT scan and had algorithms to find out whether that person has a bleeding stroke, the hemorrhagic stroke. We call the hemorrhagic stroke. There are two different kinds of strokes: ischemic stroke and hemorrhagic stroke. And hemorrhagic stroke is something to do with the brain has bleeding. And the CAT scan, this AI algorithm was able to detect and diagnose the hemorrhagic stroke very accurately. And in 2018, as all of you probably know about that, the smartwatch has the AFib detection algorithm in Apple Watch. And also in 2020, in this year, early, probably March, I remember, and ultrasound can be used for the cardiac disease. So here you can see the table that which algorithms have been approved by the FDA. So go back to the study, the purpose of this study was to build a deep learning algorithm to predict the self-reported poor health based on the aging, behavioral, and demographic factors as the groundwork for the future targeted intervention for Black and Hispanic caregivers with MCI in the United States. So our team used a behavioral risk factor surveillance system, PRFSS, which is open to the public. If you go to the www.cdc.gov/PRFSS, you can download all the population-based random digitizer, the health survey from 1984 until 2019. And I think 2020, you can get the 2020 data next year around June, or probably because of the COVID, probably it is delayed. I expect it's going to be a little bit of delay. And the sample size was 1.3 million, and time frame was from 2016 to 18. And cross-validation, for the cross-validation, the data set was randomly divided into training and evaluation data set. By the way, hi, I'm a postgraduate student for AI. Yes, okay, great. Thanks for posting. I'm just checking the posting so that I know who you are. So outcome variable was a self-reported poor health, which is just one question at a whole data set. And to rank the respondents were asked to rank their general health on 5-point Likert scale, and 1 to 3, excellent, very good, and good were categorized as good health, and 4 and 5, fair and good, was categorized as the poor health. So target population, I use the caregivers with MCI, but you can use some other target population too. That data set is not only for the caregivers data set, it is a whole population data set. So you can use the people in the Americans with high blood pressure, or Americans with, or everyone. You can use it, and you can also publish the paper. You can build a nice AI algorithm. And the question I used for the target population was, during the past 12 months, have you experienced the confusion or memory loss that is happening more often, or is getting worse? That question I used for the MCI, the mild cognitive impairment. And tool I used the R3.6 WCAG. Anybody familiar with the WCAG or Big ML? Can you write it in the question and answer? Pain?
Sorry, I didn't know if I was going to enter the meeting. Mute or unmute.
Oh, Weka, yes, okay, great. Weka is, I've been using Weka for 10 years, and I'm a big fan of Weka because Weka is great. We can discuss later in the discussion why I like Weka, and how we're going to use Python and R and Weka all together. So this is the method. So CDC as actually this is the BRFS is a state-based survey, but then they use the same questionnaire, the core questionnaire, and the state can add. So at CDC, the BRFS population surveyors, they ask the question using the telephone, home phone or mobile phone. And then it is about 280 questionnaires. And as far as I remember, it was like 350 variables sometimes, or it's less, but then you can make it larger dimension from one question, right? So what we do is we choose I really want to use the laser point. However, somehow it just breaks the flow and it just, I cannot, it did not work. So I have to close the slides, so I cannot use it. So please forgive me not using the laser point. So 71 variables were first selected by the domain experts. Then after the human hand picking, then let the machine with Weka or BigML or R to extract further variables, like select 8 more variables. So from the literature too. So using the machine, and we did the feature selection. Then once we had the handful variables, then what we did was, there you go. We further categorize by the demographic factors, physiological factors, behavioral factors, and environmental factors, which is very important. It looks like very simple, but then this is how we succeed all the time when we make the when we do the modeling and then supervised learning. So the categorization, then once again we put the AI, the machine learning algorithm, and with the help of AI, we create the final model based on the evaluation and the performance and the meaningfulness. And of course, throughout these phases, the domain experts are the role of the domain expertise are very important. So domain experts have to give the input for the selecting the prime filtering from the beginning, and also the categorization and feature selection probably that the machine does. But then also within the health science, we have to have, we cannot just allow the computer does what they want. So we have to have every single variables have to have the literature and the rationale and support those. And then the categorize, and let the human categorize, well, which one is which, so that make sure that we don't have the redundancy, and to make sure we will have something we can make sense of it at the end. So then we have end products. So let's see what was our end product. Oh, it wasn't a laser. I cannot. Okay, there you go. So the deep neural network, I'm sure that all of you, except probably few, are not familiar, are all familiar with the deep neural network in AI. So deep neural network is an artificial neural network with multiple hidden layers between the input and output layers. And each success layer uses the output from the previous layer as an input. As you can see, the hidden layers, if it's more than 2 layers, then we call the deep learning, deep neural network. And this study, we chose the auto structure suggestion by the big ML. We can use a webcam, we can use something else, but somehow big ML really it is very quick and efficient. So we use the big ML, and for the network architecture, the number of the hidden layers and number of the nodes and the algorithms, we just used some default setting. So the result, these are the characteristics of the participant. So caregivers were 897 out of 1.3 million people with MCI, I mean, who had a problem with a cognitive decline, and which is 0.07% of the population. And age, those caregivers with cognitive impairment were age 65 and older were 44%, and over half of the caregivers with MCI were female, and one of the 10 participants were Black or Hispanic caregivers, and half of the caregivers with MCI reported poor health. So poor health means it's really poor health, and as you can see, the Black and Hispanic caregivers had a lower income, less than $25,000 per year, compared to the other non-Black or Hispanic, had only 40% of the people had less than $25,000 income per year. Per year, it's not per month. So this is the result. The factors importance for the poor health applying deep learning. Aging was very important, and weight also was very important. So age and weight were, however, excluded in the final prediction model because it is relatively it has a lack of interpretability. So for example, it can be a confounder. I can mention later, we can discuss about it later. It can be the age and weight can be a proxy for the number of chronic diseases. And it can be a possible confounder. So this is the model. So the Black and Hispanic caregivers with MCI under the poverty, whose MCI symptoms have interfered with the social activities during the past 12 months, were likely to report being in poor health, regardless of their caregiving duration, whether inexperienced or experienced. So I remember that one of the person, what is her name? Yeah, home care agency. Okay. Dandy? Oh, probably you are not able to talk. Oh, okay. So hopefully this makes sense to Nandy. Nandy works for the home care agency. So for a non-Hispanic or non-Black caregivers with MCI, like Caucasians, Asians with mild cognitive impairment, the novel finding were observed for those who use electronic cigarettes. As you can see over here, among the caregivers who exercised and have MCI symptoms interfering with the social activities, the use of the cigarette increased their probability of experiencing poor health. So as you can see, no matter even though you exercise, or the MCI, you sometimes have it or always have it, but you will likely to have a poor health if you smoke the e-cigarette. So of course, the deep learning, the ROC curve, the deep learning, which is the blue color, has the highest the evaluation, the ROC curve. AUC area. Okay, and the discussion. So behavior is exercise enough to improve the general health? Here's an answer. Can you hear me? No, I cannot hear you. Okay, so Nettie, do you think is exercise enough to improve the general health for the caregivers? Okay, I just assume that you say yes. All right, so but then our study suggests that if you smoke, smoke of course is the worst thing, as you know. But then if you smoke the e-cigarette, that's the problem. So our study suggests the cessation of the cigarette smoking is a treatment when MCI symptoms occur. So once one person has the pre-dementia, the cognitive impairment, then definitely the e-cigarette has to be stopped rather than using the exercise counseling alone. So now for the computer science folks, so AI has a potential to transform the healthcare, as you all know, from the big data generated every single day. So as you can see, there are so many big data. Immune system, gut, microbiome, the family history, labs, all electronic health records, social media data, conventional data, survey data, lab data, right, which is part of the electronic health records. And you can apply the AI, and you can definitely improve the outcome of our health. However, there are many potential potential input layers. However, the problem we have, which has not been solved for the past 40 years, as you know, the AI has been applied in medicine since 1950, 1960. It has been for a long time. We had the first AI system called Mycin. Probably Nettie knows or heard about it or not heard about it, but we have Mycin to help the doctors to prescribe the correct antibiotics. However, somehow for 40 years, past 40 years, it was not used because of the volume of the data, the computing system, and also the not good the people like you, right? So now, still, it has not much improved for past 50 years because it is still remain as a black box. So has biggest limitation of lack of transparency and interpretability. That's the big problem. It does not have an uptake for the doctors. So let me give you the real world example that I've been modeling. I've been applying the machine learning past 12, 13 years and publishing it in health science. And a lot of times I get a lot of critiques and also a lot of discouragement too. And even what I've heard was that my proposals are not worth to read, and that's the response I get from statisticians or traditional scientists. They understand factor analysis, or they understand certain things, but and clustering, I mean, but they're not necessarily understand and welcome the AI. So one reason, the biggest reason, is its lack of the transparency and interpretability, because we poorly did the interaction and or adaptation of the process. So it has to be very transparent. So what are the issues? The first one, okay, I'm waiting for my slide working. It's already 4. Okay, good. So the first one, the first issue is the framing issue. So the clinician, so the further framing issue, we have to let the clinicians or the researchers or providers, doctors and nurses, and scientists, traditional scientists, they have to let them review of the input, so that we can go forward and make the science evolve. So our team, for this paper, we use 20 to 30 years of the expertise. We use the domain experts with the 20 to 30 years of the expertise, a lot of them. And the second issue is that the trusting issue. So the people trust our outcome or people trust our what the computer have to say. So what we have to do is a transparency issue, right? So we have to use something to show, be transparent. Not necessarily I really like the C4.5, but then if you at least show 3 algorithms, or a tree algorithms has several algorithms, right? And for example, C4.5, then you will be able to convince and persuade the domain experts. 3, we have a problem with amplifying bias in the historical data. So what we have to do is we have to identify the confounders, which is pretty much art. So we have to think hard, and then we have to, for this case, this paper, age and weight were identified as confounders. And of course, we have to have literature to support that, why it is a confounders. So of course, the algorithms can identify and remove the redundancy, and it by itself it removes the redundancy, it calculates those things, but then humans still have to there are room for the human to actually review it too. It's not like the machines cannot know about the redundancy of the real redundancy. So, and number 4, the fourth issue is that the practice workflow disruption issue, which is a huge thing. So probably some Nettie, there is only one probably with the health kind of environment, and then probably you heard about the alert fatigue, and among the clinicians and health providers. So which is very common. So for example, it can actually, it is not even common, but then it is also very, very harmful too. So for example, if I have an alert alarm by the AI, whatever the algorithm someone made it, and then I have an alarm and keep saying that if you don't take out this medication right now from the pharmacy machine or something, and then morphine or whatever medication, and then I am not going to be able to pick up the medication after 10 minutes or 5 minutes. That's how they make the algorithm. However, what if my patient is having a seizure right now? Can I go and take the medication for the just satisfying for the machine? No. And a lot of AI projects and jobs have been just ignoring the clinical workflow or human workflow. So we have to make sure that we don't disturb the workflow. So so what we have to do is we have to overcome that problem. We have to actually make our finding as a simple and novel findings instead of the very complicated, nobody knows, and then unrecognizable or not so much considering the workflow. So conclusion was that our deep learning algorithm revealed the strongest predictors of the self-reported poor health among the caregiver with mild cognitive impairment to be aging and frequency of symptoms, interference with social activities, and exercise, e-cigarette use, and income, which is sad. And this new knowledge will actually used for our one of the R1 project, which is supported by the National Institute of Aging to create the intervention for them. Let's go to the second part. Do you have any question? If you have any question, could you please write it down in the question and answer before I go to the second one?
Looks like there's a question already in there, right at the bottom, or two so far, two already.
All right, so if all participants in the MCI study had a similar low income, would the result have changed? So what you mean by is probably we will not have enough power. So EM, we will not have enough power. So we will not even able to build any prediction model. So I will come back that question later. So the part 2, now, can you see this part 2 slide, the Twitter one? Tom, can you see this part 2 slide?
Yeah, I can see
great.
it.
Okay, finally, let's come back to the Twitter. So I know that you are here for the Twitter talk instead of the traditional one, right? But a traditional data, using the conventional data is quick and easy. So that's why I just use it first. So the part 2 will be very short. I'm just going to, because I assume that the computer scientists, they all know about the Twitter analytics. So I'm going to go very quick, very fast. So let me see. Okay, so for the Twitter analytics, we need a map to actually explore the tweet data. So Dr. Kwon mentioned that don't waste your time working on the wrong question. She is not a Twitter analytic person, but she is a health service researcher. So the fundamental question 1, I know so far can be pretty boring with the conventional data analytics. So, but then probably next 2 slides, this slide and the next one can help you a lot with your real world analytic problem. So the first one, what question we have to ask to the Twitter is what question? So we can learn it from Aristotle and Plato. These 2 people are those, and what they asked the question was actually the fundamental question was what they are. Is it animal or is it vegetable? For Twitter, we can say for the COVID tweet, let's say COVID tweet. Oh, is it harmful? Is it misinformation or disinformation? Or misinformation, disinformation, or true? We can build an algorithm that, right? And I'm sure that the Twitter also build those algorithms, and they are tagging all those election related tweets, right? So we can build is it true or is it first? Is it animal or is it vegetable? Is it misinformation or is it helpful information, right? And then the second fundamental question we can ask is the structure-minded questions. What are the structures? So, for example, in macro and micro and macro, meso, and micro level. So from a child verbal description of the snowflake, the concept of the structure is an essential foundation of early very mode of the inquiry. So any inquiry, any discovery in science, philosophy, and art. So structure question is fundamental question number 2. So what kind of questions you can ask? You can see the next slide. I write it down well. So what are the changes of this macro level of the people? Like for example, for the election or for the COVID, you can say, oh, how many people, what are the changes on this structure, networking structure on the people who mentioned about the COVID among different population, and what are the time changes? What are the communities, and how many isolates are there? How many small groups are there? And I will go into deeper later. So in 1948, Shannon and Weaver, probably some of you, many of you already are very familiar with this theoretical framework. He mentioned that information source can be transferred by the transmitter and strengthened and weakened by noisy source, and that the person, the receiver, received the signal, the message, and then it goes to destination, the enactment, and to the behavior. So I put those in 2010 that put the Twitter. So information sources, Twitter users who create the tweets, and then the transmitter can be a Twitter. You can put the Reddit, you can put the Facebook, you can put Instagram, and so on, and YouTube too. Then it can be, those messages can be strengthened or weakened by receivers' belief, knowledge, attitude, or their peers too. Then followers of the Twitter can receive it as what they want. And then they will act, they will go out and do the protest, and they will do the talk something. So that is a possible enactment. At the same time, if it's too mathematical, Laswell also reported that what kind of questions we can ask to the medium in 1948. So who is a control question, control research, and says what is a content research. So we apply the topic modeling, we apply the LDA, NMF, right? And in what channel is a medium research. So as you can see, the Instagram people are a little younger than not Twitter, but the Facebook. And so the medium has its own characters. The audience of the medium has its own different characters. And to whom, and the Facebook audience and Twitter audience, they can be a little bit different. So in terms of the demographics or other things. And with what effect is the effect research. So in 2010, when Twitter was formed, I wrote a dissertation on Twitter analytics on digital activity topic. So you randomly import the tweets and using the APIs, and you either go this way or this way. So the upper way is a network analysis, applying the social network analysis, so that you understand the social structure, the network structure of the tweets, as I briefly mentioned. Or you can go to the text mining, the content analysis. The sentiment analysis belong to the content analysis too. So then you can see the trend of the content and applying the natural language processing. The questions you can ask is, what are the structure changes of the tweet network? And who are the main communities and leaders? Okay, it's 350, so. And the network of the tweets over time, what topics of the content emerge over time, or what are the weekly trends of the content? This is the pipeline. Okay, so now the case studies. So Twitter, with Twitter data, which is open to the public, you can help with chronic disease like dementia or dementia caregivers, or you can also help a lot for the society for the acute disease, like including the Ebola, emerging disease like COVID. So what we found, Dr. Oldham and I found that the Twitter can give the Nigeria an early Ebola warning sign, and it has been reached out to actually 45 plus medium, including even South Africa and the areas where we can reach hard. But then we were able to reach even those African areas and European countries too. So it wasn't only our team, but the post team from University of Pennsylvania also found out that the Twitter, the rate of the instance of the people talking about the flu vaccine, getting flu, and also the CDC report of the instance of the flu were highly correlated. The correlation coefficient was 0.95. So this was the MERS, applying the topic modeling, NMF, at the first early phase. We found that the fear, distrust in government. And the second, in the middle time, we found that a lot of people have to blame someone, blaming Samsung politicians, and they play fear. So it was horrible in the middle time, mid phase. And then at the end, actually, Korea was able to get over the MERS within 2 weeks, 2 months, I think, I remember. And at the end, actually, people were encouraging a lot to the clinicians. And as you can see a lot of heart and encouragement in the tweets. So then they were in hand washing too. So we can learn those things. We can learn those the behavior, so that we can instead of we blame someone, we have to encourage someone, and that is the time that we have a better curve. So that was the content analysis, and now let's move on to the social network analysis, the structure mining. Node represent a Twitter user, and line represent the retweet. A lot of times nowadays, a lot of people just remove applying the bot detection algorithm and remove retweet, but and just use the unique tweets. But removing the bot is fine. However, removing the retweet, you have to think one more time, because it's like retweet is another way to express themselves too. So what if one person, if I say something in the Twitter and then one person no one retweet, and if let me just pick one person, Sandeep tweet about the COVID virus or something, and an AI algorithm, and then he has millions of followers, let's say that, and how can my tweet and his tweet the same as in terms of the analyze the tweets? So I understand that a lot of times right now people just use the bot removing algorithm to remove the bot. However, you have to think one more time about what you are applying conceptually, because it's like in the people with the sociology the base, and I also can say that I'm not very sure that what kind of novel findings you can get it from removing all the retweet and just working on the unique tweets. And then this, okay, let's say this is for actually Neddy. So there are a lot of people who are familiar with the social network, the visualization. A lot of people don't understand, and they are not ready in the health science. I'm sure a lot of people, the doctors and nurses, are not ready to read and see the network visualization. So I have to use this the egg. So let's say time 1 of the MERS infection, because MERS is the only one that now we clearly it is gone, but we are in the middle of the pandemic. Probably we can learn something from the MERS case too. So the time 1 was from the June 1st to 6th, and the time 2 is the middle, and the time 3 was the late part of the thing. And then the core part for the network visualization, we call the core the people with the large groups and isolate in the periphery. So egg. Let's think about the egg, how it changes from the time 1 to 3. Once after a month later, the egg core can be dissolved tremendously, and you will not able to see the margins anymore. And I saw the English twist mentioning the MERS happens the same. But in Korean tweets, I saw which was a little different. The core tweets were more actually getting more of large groups. And from the beginning, only few people, isolated groups, were talking each other, but not each other, by themselves. However, at the end, you can see they are connected each other. So let's move on to the chronic disease dementia. So Twitter can be used. The tweet data can be used as a training data for AI, and also we can compare the traditional interview data from the caregivers and also social media data. So when we compare the emotional score of the focus group, which I used the traditional methodology of interview among Hispanic dementia caregivers, and tweets mentioning about dementia caregiving related keywords. And then I found out, our team found out that the negative sentiment, as you can see, the overall were similar. You don't have a lot of a strong negative or positive. On the left is a focus group using the interview data in person, and on the right, I used the tweet data. And as you can see, both of them are very similar. However, in the focus group data, you can see more strong positive emotion, which we call the social desirability. So if we use a traditional data, instead of social media data, we can see more of a positive sentiment. And that does not necessarily help our research, because the research question was how we can help for the stress of the dementia caregivers. And if they all say, oh, I'm good, I'm okay, I'm trying, I'm all set, I don't need any help, you know, we don't need those kind of things. We cannot help them. So, but Twitter, we can see very distinct cluster of negative sentiment. Oh, I'm dying. It's so difficult. It's so hard for me to take care of my father. I have a problem with taking care of my father. Those kind of things. People actually express themselves and talk about it. But what we found was that they talk by themselves and no one actually can help them. And no one was retweeting or replying to them, and no one was interacting with them. We saw a lot of those caregivers were isolated. So, okay, so because of time, probably we'll quickly go over this slide. So as you can see, the topics can shift from year by year. So 1 year can talk about home care, marijuana use, but then another year, like now in 2020, is all about the COVID, and now we're in the process of do the publication, and what we found was that people were more talking about anxiety and depression and also coping, but the most need among the caregivers were actually the nursing home placement, home care. However, those were decreased somehow. So now let's move on to the social network analysis on dementia, the chronic disease, which is chronic disease. So as you can see, 1 year the core part can have a lot of the people talking about it, but the next year it can be shrinked, but the periphery or the small group can be increased. So what does that mean? So small group from the sociology can say that the small group is actually really helpful in providing the social support. So by theory, in theory, increased number of the small group. Small group is defined as 2 to, or some people said 7 to 20 people group can actually help for your basic needs like belongingness and remove your loneliness and can help you. So we saw in 2015 and 16 more and more people were actually talking with dementia caregivers in the Twitter, and we can see the lesser people were isolated. So okay, so that's it, and thank you so much for listening. If you have any question, please write down in the question and answer. Okay. Did you try to, okay, let me read. Did you try to so-called the rule-based approach like Rob said? So what is a rule-based? Can you tell me can you tell me more about the rule-based approach? You mean the supervised one? Are you talking about the supervised learning or unsupervised learning or classifiers? Which rule are you talking about? Because in the by the discipline we have different names. Okay, until Arthur write further, I will go. We'll take another question. So if all the participants in the MCI study had a similar income level, oh, okay, yeah, that I think I answered. Would it have been better to ask a relative or friend in addition to instead of? Can we discuss at the end of this talk? Would a person with MCI be a reliable participant to evaluate their own memory? No, would a person, so Ian asked that, would a person with MCI be a reliable participant to evaluate their own memory? That is the limitation of self-report. Okay, I don't have any other questions. Tom.
All right. Well, it looks like there's no more. But thank you so much for coming, Sunmoo, and thank you for your time. It was a really interesting workshop. I enjoyed it a lot. I'm sure everyone else listening did too. We at Magnimind hold these talks to keep people furthering their learning and inspiring people to do more in their field. So if you came here today, thank you. And you've been doing that. That's wonderful. If you haven't already, please make sure to subscribe to our YouTube channel, which is called Magnimind Academy, and please comment what you thought about today's meetup or what you think about our online student format. Also, please join us for our next scheduled meetup, which is going to be on November 25th, called Data Science for Managers, and it's a workshop. Thank you, everyone, and have a good day or night, wherever you're coming from. Oh, and the link to the channel I can do that right now.
Now I see the chat, so if I ever ignore anything, I did not mean to, because it's like I didn't have the chat before. So Tom, I will just I will stay for a couple of minutes to answer those questions, okay, in the chat.
Sure. Yeah. Yeah. I'll go ahead. I just put the link for the YouTube channel in the comment section. And yes, we'll have this talk posted as soon as we're done, and then we have to render it, and then it'll be on. So probably like an hour after we're done with this. Sunmoo, do you think you could send me the slides to the presentation that you had today? I can distribute them to the people who are asking them in the chat.
Sure.
Yeah. Okay. Perfect. Do that. Okay. It looks like I don't see any other questions. Thank you so much, everyone, for coming. And have a good rest of your day. All right. Goodbye.